Alright, we want to look at finding vectors, in this case finding resultant vectors. So we're looking at resultant vector being the sum of two or more. So if we have vector u and vector v, for example, like, well, we've taken and we put vector v tail to tip with vector u, and then we said the resultant vector would have been whatever this vector would be when you go tail to tip. This right here is what the resultant would look like. Now, the steps to find the resultant vector are as follows. You first want to find the x components, then find the y components, or do that in the same step. You need to do that for all of them. The picture will definitely help. The next step is to find theta, which we're going to use with tangent of theta, and we're going to leave this as positive. I'll tell you what that means in a minute. And then the last step is to find the magnitude of the vector, which you can do either with sine or by doing the magnitude, the length that we've done with the square root before. So let's do an example so you can see exactly how this works. Okay, these are two vectors. These are dealing with newtons. That's what this NT stands for. So first thing you want to look at is, if I draw a picture, what does it look like? The picture should look like, well, 150 degrees is somewhere in quadrant 2, so something like that for F1. As for F2, it's at 315 degrees, and the magnitude is only 103, so it's not nearly as much as the other one. So something kind of like that for F2. Now, if we were to look and say, well, what should this resultant vector look like? Well, if I did something like this, it appears that the resultant should be something in quadrant 2. It should be something that kind of looks like that. So we assume it should be in quadrant 2. So we need to now confirm that that is definitely true. So to do that, here's what we need to find. We need to look at the x component, and we need to look at the y component. So we'll start with x. So we first want to look with F1. With F1, what we have to find the x component is we would say, well, cosine of my angle is always going to be x over r. And if we look at our original picture, let me get that out of the way again so you can see it. Our original picture right here, remember we said we would do something like this with a right triangle? Well, we would have, this is a y, this is an x, and this up here is 216. Well, here's my theta. The x component right here over 216 is my angle for theta. So what angle would I use? Well, we've said before that we needed to use reference angles and everything. When we're doing this here, we don't even need to. We can go and plug in the angle directly. We can say cosine of 150 is equal to x over r. R is the radius or the actual magnitude, 216. That means x is equal to 216 times cosine of 150, or when we plug that in, that's going to be negative 187.06. Now, cosine, we're in the second quadrant, it should be negative, so that should make perfect sense for you. We want to do the same thing for our second vector. So vector 2, we're going to do the same thing. Cosine of, in this case, we have 315 degrees, is equal to x over 103. So x equals 103 cosine of 315, or that means that x is equal to, in the end, 72.83. What we now want to do is take the sum of those two. We have two different answers for our x components for the two. So to find the resultant, I'm going to call this f of r the resultant vector. To do that, we're just going to add them. Add 72.83 and negative 187. And that means my answer is going to be negative 114.23 for my x component. And we're going to do the same thing for the y components. We're going to have F1, we're going to have F2, and I'm going to find, in the end, another one in FR for my n, for the x component. So this is what x equaled, and now I'm going to find what y equals in the end. So for this one, same thing, except now to get y, I should be looking at the sine. So I'm going to say that sine of 150 is equal to y over 216. So that means that y is 216 times sine of 150. That means that y is going to equal, when I plug that in, I'm going to get 108 for that one. I'll do the same for vector 2. I'm going to get sine of 315 is y over 103. So y equals 103 sine of 315. and that means that y in this case will equal a negative 72.83. Again, positive in the second quadrant, that's why this is positive, and negative in the fourth quadrant, that's why we get a negative for this one. So same thing we're going to do here. Here are my y components. I need to add them up, and that's what my resultant y component will be. In this case, 35.17. So far we have done. This is part 1. This is part 2. Now we need to go to part 3, which is to find the angle of our resultant vector. To do that, what we need to look at is, I don't want to say this. We need to look at what angle it is. And to do that, we're going to be using tangent of theta, which is equal to, if we look at any theta, it's going to be y over x. Y over x. Before I even do that, we want to say, well, what quadrant should I even be in to begin with? Well, we assumed it was going to be in the second quadrant. That's what it looked like. Now, the way to tell for sure, when is x negative and y positive? So x is negative, y is positive. Yes, we are in quadrant 2 for sure. So that means what I need to do now is to see what my reference angle is going to be. So say the resultant vector comes out to right about there. So I need to do the same thing and say, what is this going to be? What is my x value? What is my y value? What is this little reference angle going to look like? To do that, tangent of theta equals y over x. I'm going to simplify that by plugging in y and x, but I want these numbers to be positive. That way I'm guaranteed to get a positive angle, and I don't have to worry about guessing and checking. I'm just going to make a positive angle, and that's what my reference angle will be. So that means theta will be the inverse tangent of this fraction, 35.17 over 114.23. When I plug that in into my calculator, I'm going to get theta is equal to 17.11 degrees. So that's what my reference angle is. Again, I'm in the second quadrant, so how much more do I need? Because I want to look at what this angle is here. So to do that, I'm going to do 180 minus 17.11, which means the angle I'm worried about is going to be 162.89 degrees. That's my angle. That's what I want to look at. So that's part 3. Now, the last part, part 4, is where things get a little bit trickier. We have a couple options though to find our length. The first one is to use sine. Sine of theta is equal to y over r. Well, we know what y is from down here. We don't know what r is yet. That's what we need to find. R, how long this is. So that would be y over sine of theta. And we know what theta is because we just found it. So that means r is equal to y, 35.17, divided by sine of theta, sine of 162.89 degrees. And when we do that, we'll solve, and we should get that r is equal to about 119.54 newtons. That means that in the end, my answer is, write it down here in yellow, my answer is, the resultant vector is equal to 119.54 newtons, that's what we got from part 4 up here, at what degree? At what angle? That's what we got in part 3. At 162.89 degrees. That's how you want your final answer to look. Now, I said there are a couple ways you could do part 4. The other way to do part 4 is by doing the magnitude. And we did that by saying it is that r would equal the square root of x squared plus y squared. Kind of like the good old Pythagorean theorem. So I would do r is equal to the square root of, I'm going to take negative 114.23, square it, and add that to 35.17 and square it. And I can go that way as well. When I do that, I think I end up getting 119.53 instead of 5.4. So same thing, a little bit of a rounding issue here and there, but close enough. Either one of those is a fine way to get r. In the end, this is what you want down here in yellow. You need 119.54 newtons at that angle.